Well, it's Christmas Eve, the 24th of December, and welcome to the final instalment of the Haynes Build Your Own FM Radio Advent Calendar. I hope everyone's enjoyed watching along with this, and it might encourage a few of you to either buy a breadboard or maybe buy a couple kits and try and put together yourself. There's plenty of radio kits out there. I've got one up on the shelf I was given last Christmas, so I don't think I did a video on that, which is a shame, but I'll pop that down perhaps at the end of this video, just show you that one. Something you can easily pick up from someone like Maplins or any of the big electronic retailers. So I'd like to thank all my subscribers for subscribing this year. It's not the end of the year yet, I know, but I have got quite a few videos in the pipeline that I've already shot, so I'll be popping those out over the next couple of weeks, hopefully. I've got the final instalments of the Bush VTR. I've also got a Hacker Helmsman restoration I did, which is really interesting. A few issues with that one at the end as well, which is quite interesting watching, I'm sure. Then I've got an AOR 3000, and yeah, that one gave me a lot of a headache. A big headache. So that one is working at last. And I've got an MFJ amateur radio 20 meter transceiver that I worked on and got up and running again. And my current project is I got a Roberts R 861. So loads and loads to come. So hopefully I don't bore you stupid, but it gives you something to watch while you're while you're off on holiday. Mrs. might be watching all the girly films, and you might think, let's just nip up on the computer and watch a bit of radio. Anyway, without further ado, let's get on to day 24 of the Haynes Radio Advent Calendar. Well, here we are, number 24 over here. So let's just pop that one open. I've got the tweezers to hand at the moment. And we have a resistor. It looks like brown, black and white. Or was it yellow? I can't see. Must be going colourblind. That's brown, black and yellow by the looks of it. So let's get that out of the way. Don't need to hide anything now. We've got this is the last one. So day 24 is entitled 24 Saving Electricity. So there's a 100k resistor, which is brown, black, yellow, so my eyes weren't deceiving me. So this is used as the switching transistor's base resistor for the LED. The switching transistor's base resistor, okay. So the switching transistor for the LED is, I thought it was, pass which one that is. I thought it was this one here, BC557C, the on-off, but I don't think we're rejigging that. No. Okay. So it's 100 nanofarad capacitors inserted between the base and the collector. Oh, I see, yeah, I can see that one there. Yeah, that wasn't in there before. Looks like then that resistor's been changed to 100k instead of 4.7k, and that's been linked into pin 1 by the looks of the audio IC, or the amplifier chip. Okay, so I'm jumping ahead here, look. As I say, 100 nanofarad capacitors inserted between the base and the collector. This evens the LED current, thereby avoiding fluctuations in the audio signal. And I did notice that when I was messing about with some power on this yesterday, I didn't do that on camera, it was off camera, but I was turning the power up and down, and at very low power that LED did flicker an awful lot, so hopefully that'll make that more stable. And again, I also tested the current current draw on this, and that was really affected by the audio. So again, that might smooth that out as well, hopefully. So the modification results in a further improvement to the standby mode. The output amplifier is now also switched off. Well, you saw by my experiments yesterday, I think it was, that the amplifier or the circuit in standby mode was still drawing 3 milliamps. So it features a switch off input on pin 1. That's where this is coming from then. So when this one here is activated, it's switching off pin 1 by the looks of it. That's LED driving transistor. So it says the operating current drops to almost zero when a voltage is applied. So basically put voltage on pin 1 and it's going to drop the operating current to zero virtually. So this means the batteries will last for considerably longer. So during actual use, the consumption in standby mode drops to 0.2 milliamps. So it's gone from 3 to 0.2, meaning that batteries only need to be removed when not using the radio for long periods lasting several days. So in other words, now instead of unplugging the battery all the time, you can just hit the standby, and that knocks it off dead. Brilliant. In addition, a 4.7 kilo ohm resistor is connected in parallel to the LED is necessary, so that the voltage on pin 1 of the amplifier can increase sufficiently. 4. Yeah, okay, there we are. That's this one here at the top. So let's get the picture out and have a look. Then what I'll do is I'll look at actually what we'll do is I'll do the current draw first. We'll do before and after. How am I going to do this? I actually don't know if I showed that yesterday. Yeah, I think it was around 60 milliamps when it was turned on, and in standby mode it's 3 milliamps. I need to just rig up the circuit. Let's just stick a jumper wire in there. Oh yeah, forgot that terminal has had it, which is great. It's not very good either. That's a better one. So you can see what I've done. I've broken the wire. Well, actually broken. Let's get that out of the way. Let's zoom you in a little bit closer. Let's come down there. So yeah, you can see I've basically put a break in this wire here so I can check the current flowing. So I'm going to get my meter up. So we'll check it before and after we do this modification to see what the difference is. I need to get those leads changed around. Let's just zoom you back out again so you can see what I'm doing. There we go. Hopefully you can see that. So say I've just swapped the leads around so as it's in the ampage position. I keep forgetting to do that and wonder why it won't read it. Let's turn it on to milliamps scale. Let's leave it on that one. Don't need too high a resolution for this. Let's connect that up to those two wires then. So this is basically going to be putting power into the unit now from the batteries, hopefully. So you can see there in off mode, no LED lit. If you can see that, we're drawing 3.1 milliamps. If I switch it on, around 24 now. If I turn the volume right down, so minimum volume we're on 23. Let's make a note of this. 24 milliamps at 0 volts. Sorry, volume minimum, and then with it in standby, 3.1 milliamps standby. Incidentally, when it's actually tuned to a station, if we can find one, oh, I changed it yesterday, didn't I? I forgot the I've got the volume on these buttons now.
First, let's say good afternoon to Gary in North, and a request please.
So full volume.
Gillis, and Gary says, I've been listening to Classic FM since
it's all over the shop.
Well, we are 25 years old in 2017. How's that? Also wants to say hello to Dad. Gary's making the fire. All very festive in the house today with Classic FM on 4 radios. Carol of the Bells, please. And also the Reverend Jenny Ellis.
So
has been in touch, and Jenny says, please could you get
turn that back off again. I say that's all over the shop in.
working their socks off.
It's around 50 milliamps, I would say. Full volume. What we'll do now is I'll do the modifications to this, and we'll see what the readings are afterwards. So just disconnect that again for now. Pop that off. Zoom you in on the breadboard again. Well, we go and do the alterations. So I've also been sort of working along with this with another channel, Goglet72. So please check out his channel. He's done exactly the same kit, pretty much. Different box, but that's about it. So let's have a look at the difference in the circuits. Get the book in a minute. Get the book of words out. So it looks tiny on this video camera, but when you actually put it up on the screen, it is actually quite a big picture. So I won't overdo it. Let's say it does differ here because I got rid of that silly loop antenna which didn't work, and I reinstalled the coil and just a very short length of wire, but I will increase the length of that. We'll work it out exactly when I get to sticking this on a proper circuit board. So we've got to alter some resistors around now. So the 1K, okay, the 1K is staying in. That one's coming out. Moving up to here by the looks of it. Hopefully you can see what I'm up to. There's not too much in the way. Big thumbs and all that. There we go. That one's in there. So at the moment that's not connected to a lot, so I've got to pull out the 4.7. Let's get rid of that one a minute. That's gone. I've got to put this one to the base of that capacitor and pop it over right over here. Let's get that out of the way. To the L. Just above that other wire. Okay. well done. Got the link in there still. Little link in there. It's tricky this because they don't always tell you what exactly you're supposed to be doing. So okay, so now the 4.7K goes back in the top. Let's put in power back into that LED. Pop it in there. Not quite the exact hole, but it's still the positive route. And we're going to pop that down into that hole there. Tricky. Getting very busy down here. Resistor City. There we are. I double check again because I keep forgetting to put bits in here. That's in there. Speaker's not moving. Okay. Right, this transistor is altering. Ah, that's sneaky, isn't it? Didn't tell you that. This down here is altering. I think Dave might not have done this bit. If you have, Dave, apologies, but if you haven't, that transistor needs to move there. And we need to stick another link in. So I've got a link here already, it's in black, but yeah. So that's going from this transistor down into the first pin of that IC, down in there. There we go, just as well I double check that really, because that is what is going to do the business. So yeah, you need that black link in there. It's in black on mine unfortunately, but let's get in a little bit closer there. So that's the link. Let's get the light in a bit better. That's the black link there. So it's basically linking, I think it's the base, isn't it? Just linking the base down into pin 1 of that. Let's just double check that on the circuit diagram. No, it's not. It's actually the collector to pin 1. There we go. Right. Let's zoom you out. Get the meter back into the bench. Is a bit of a mess here at the moment. I'm just been doing some experiments with, as you see by my like spaghetti breadboard here, that I've got a battery holder for a lithium-ion battery and some Zener diodes, but unfortunately the Zener diode that I thought would do the trick, it does to a certain extent, but it does need a couple volts more than the output voltage you're expecting. So I'm looking for, say, 3 to 3.5 volts. So I really need 5 or 6 volts on the input to make it work properly, which is not going to be possible because Dave, who I'm looking at this for, has only got these slightly different than this, but 3.7 volts. So I have found a voltage regulator that will work on a very low voltage in with a similarly low voltage out. Not much differential. I can't remember what, so I'm assuming it's a low differential regulator or something like that. I can't remember what it's called off the top of my head. Anyway, I'm deviating, that's what the mess is. So let's connect it up then. Let's get the meter back on milliamps. Hopefully you can see that, not too much glare. Let's get this back up out of the way a little bit. Yeah, you should be able to see that. Let's connect this up then. So on. There we go, they're dead right, that. So we're looking at, zoom you in, 0.22 of a milliamp. Now before it was 3.1 milliamps in standby alert. So let's turn it on. Turn the volume right down. So that's really hasn't changed, 23, 24 milliamps. Turn the volume up. Same as find a station. Cool. I'll turn that down. Sounds like an Exeter Chiefs rugby game. So again, we're the same. The big benefit is, in standby mode, 0.2 milliamps, exactly as they've said. So yeah, pretty good. So now what this means is it can be left like that for long periods of time. And if we can rig Dave up with his rechargeable batteries, then this could last a very long time. Anyway, thanks for watching. I hope you've enjoyed this. Watch out for all my other videos. Plenty coming up soon for you radio fans. If you want to see any more of this sort of thing, then let me know. And any real suggestions for the channel for the rest of this year and next year, let me know. Anything you prefer to watch or don't prefer to watch, you don't want to see me waffling, all that sort of stuff, then just let me know. If you like it, give me a thumbs up, and I'll see you all on the next video. And I will get this set up permanently, and we'll get it out of the breadboard and onto some strip boards, so watch out for that. Bye for now. And just one last thing, have a great Christmas. Don't drink too much. Bye for now.